Hey guys, so the purpose of this screencast is just to express the fundamental differences between ionic versus molecular compounds. And I've picked just two examples here. Here is an ionic compound known as sodium chloride, and here's a molecular compound known as glucose. In other words, we'll just call it sugar. And so one of the fundamental differences that I'm going to talk about is what happens when they're placed in water. So as you drop some amount of sodium chloride in water, it sticks together the whole way, and then all of a sudden when it gets into water, something noticeable changes that we can't see with our eyes, but we can represent in this simulation. It changes, or it separates into its ions. Okay, and what I mean by that is it has a bunch of sodium ions that are positively charged, and it has a bunch of chlorine ions that are negatively charged. Okay, so it goes from this nice solid structure here to separating into its ions. If you try to do the same thing with sugar and drop some amount of sugar in there, what you would notice is that if you could see it at the molecular level, the sugar molecules actually stay together. So they were like this before, and they're also like that afterwards. Okay, so they stay together. So what you see is there's no charge on these. They're all neutral, and the sugar molecules just stay together, whereas the ionic ones split up into their own charges. Difference between the two. Another fundamental difference between the two is that the composition of them. Okay, so if you have, let's just say sodium, so this is sodium, and this is a chloride ion, so sodium chloride. What you notice is that sodium, according to this periodic table, sodium is considered to be a metal right here. And so we can dub sodium as a metal, whereas chlorine, as seen on the periodic table, chlorine's over here, it's considered to be a nonmetal. And this is the general trend for all ionic compounds, the majority of them, made up of metals and nonmetals. If you look at the composition of sugar, or in our case glucose, what you notice is that it's made up of carbon atoms, hydrogen atoms, and oxygen atoms. And if you look at the periodic table, hydrogen is a nonmetal, carbon is a nonmetal, and oxygen is a nonmetal. And so what we can do is we kind of classify these as all nonmetals. And this is one of the fundamental characteristics for the majority of molecular compounds, is that they're composed of nonmetals. All right, the last difference I want to show you is if you were to place each one in water and then put some sort of conductivity meter in there. And so what you have to kind of pretend is we have two beakers of water, and in one of them we have our sodium ions floating around, and we have the chloride ions floating around full of negative and positive charges. Okay, what you would notice is if you put some sort of conductivity probe in there with two electrodes, and then it had some sort of casing or a battery, and then from that maybe it had some sort of light bulb. It's a beautiful light bulb. What you notice is the light bulb actually, when it's turned on and placed in this solution, the light bulb actually starts to emit some light. Okay, so the big thing to take away here is that what that means is that ionic solutions are conductive. And by conductive, I mean they allow electricity to pass through. A solution full of ionic that has an ionic compound dissolved in it, because of its ions being charged, floating around, migrating from one electrode to the other, okay, they essentially bridge this gap right here and allow electricity to pass through, and therefore this light bulb to light up. If you try to do the same thing with sugar molecules involved, and let me place the sugar in there. If you try to place the same conductivity meter in this sugar-filled solution, because the molecules of sugar are all neutral and they don't have a charge on them like the ions here, no light is going to be emitted on this light bulb. Okay, and so what we can say is that it's not conductive. In other words, when molecular compounds are dissolved in water, they don't allow electricity to pass through for the most part. And so we consider them non-conductive. And so those are three fundamental differences between ionic compounds and molecular compounds.